Wouldn't it be brilliant to implement all motion control applications directly with SIMATIC? This would mean setting up the communication with drives and programming the command coordination and synchronization of access directly using Step 7 in the TIA portal. Now this dream is a reality. The S7-1500 CPU is a modern motion control system. Thanks in particular to the S7-1500 technology CPU and the integrated CAM disk functionality, we can very conveniently implement simple and complex access couplings. I'd now like to introduce this CAM disk functionality in greater detail. Let's take a closer look at the setup. To do this, I'll first switch on both axes. We can see two motors, each driven by a SINAMICS V90 servo drive. And the higher level S7-1500 technology CPU actuates the drives, providing the movement commands and coordinating and synchronizing both axes. The right axis moves continuously, and the left moves in relation to the right axis, sometimes to the right, sometimes to the left, then back to the right, and so on. This is coordinated by the SIMATIC. What could be behind an application like this? Let's take a look at an animation. Here we see two movements. The press, which is driven by means of this continuous movement, and the material infeed, which moves the material forward at the right time and at the right position of the press. This positioning relationship can be shown in the diagram, as we see here at the top. For each position of the press here on the x-axis, we see the position of the infeed, which moves forward and back accordingly. Now we want to create and configure this mathematical CAM disk here at the top in the TIA portal. To do so, we switch over to the TIA portal project. Here in our project, we've already inserted our two SINAMICS V90 converters and the S7-1500 technology CPU. In the CPU, we can already see two axes, the axis for the press and the axis for the feed. Both axes are actuated in the program, specifically by means of the system functions that provide the requirements for the traversing movements. In order to switch on the axis, for example, or to start and stop the press. Now we want to create a CAM disk in order to define the positional relationship between the press and the gripper feed. To do this, we create a technology object CAM. In the CAM disk editor now appearing, we can very easily define and optimize the CAM disk in various ways. Here we can see the x-axis, which represents the position of the master axis, in our case, the press. The y-axis of the diagram indicates the slave axis, in our case, the infeed. We'll now adapt the scaling in order to adjust it according to the units we'll be using. The press moves between 0 and 360 degrees. That's fine. We'll define the infeed so that it moves from the left side from 0 to the right side to 40. To more accurately create the CAM disk, we'll add a grid with the spacing set to 1. By doing this step, all the preparations for the creation of the CAM disk have been made. Now we want to specify at what position of the press the infeed is located on the left and when it is located on the right. In other words, when the infeed is at 0 and when it is at 40. We can either specify this graphically or use the table here at the bottom. We'll choose to do it graphically, and we defined the position of the slave axis for each position of the master axis, the press. If the press moves between 0 and 40 degrees, the infeed continues to stay at 0. If the press moves between 0 and 40, the infeed continues to stay at 0. If the press now moves farther, the infeed should then move forward. And if the press has arrived at 130 degrees, the infeed should stop at its right-hand position during the press cycle. That is, until the press has arrived at 230 degrees. Afterwards, the infeed should return again. And while the press is turning 270 degrees and 360 degrees,